Hi, everyone. Welcome to the Neos Educators stream. My name is Subjectivity, and I'm your host today. I'd like to welcome everyone here in our auditorium, as well as those watching on our Twitch stream. There will be a live Q&A after the presentation. In our series of Maker Talks, thank you. In our series of Maker Talks, we allow for creators to explain to our viewers literally how they made it, how and why they created the fascinating projects that benefit and add to NeosVR and its community. Today, I have the pleasure of introducing our presenters from the calendar team, JackTheFoxOtter and the Autopilot, who made the Neos calendar. The Neos calendar allows users to create a personal or group calendar and share it with friends. What a great community building tool, right? From what I understand, they will go into a deep explanation of the logics and other technical aspects of their project. And I think they have a few surprises planned for us too. Please join me in welcoming JackTheFoxOtter and the Autopilot.
Hello, everyone.
Hello.
All right. Let's get rid of the clapstick. Okay. Well, thank you all very much for showing up today. I'm Jack. I've been playing Neos for about 2 years actively now. And this was the second time I personally have participated in MMC, which we're going to talk about a bit more in a little bit. I hope you will enjoy the talk, and it's going to be fun.
Yeah, and I'm the Autopilot. I've been mostly a desktop user until approximately half a year ago. Finally VR. Finally can touch stuff. Well, if there was touch. And yeah, I do mainly crazy logics. So, up to you.
Yes, okay. So before we get started, I want to kind of introduce a couple of concepts here, because I already said this is going to be a bit of an experimental talk. First concept I want to introduce to you: the conversation ball. Basically just a little ball which is basically just going to be tossed to the people that are talking, and it's also going to put them in the spotlight. So once we arrive at the Q&A at the end of everything, like, you can ask your questions, but you will have to catch the ball. So be prepared for that. Also, another thing, after the Q&A is over, we will still be available for about an hour if you have any questions about the calendar, like in terms of support you need, help installing it, and help setting everything up. We will be there. We will answer your questions if you have them. So yeah, without further ado, I would say we start by just showing off the calendar. You might have already seen this. This has been a pretty massive project, honestly. But I think everyone involved was pretty happy with how it turned out. The concept here is basically pretty simple. You can have events. You have already seen a calendar before. But this is all fully contained within Neos. So we are using custom data storage, we'll also be talking about later in the talk. And the idea is you can just create your own calendars and share it with your friends. Like, we have a wizard in here which will guide you through the steps required to do that if you want. So it should be fairly straightforward to use. And then you can just subscribe to as many calendars as you want. You can hide them, you can show them. And it also comes with a built-in edit mode. So as long as you actually own the calendar, you can just go into edit mode. You can click on the plus icon on any day. You can add a test event. And if you were to save it, it will actually save it. But I am going to discard it now. And you will see that it will actually automatically update again, and the test event is once again gone. So yeah, about MMC. So we know that not everyone watching on Twitch has really been in Neos too much or at all. So the general idea of MMC is everyone can participate. They get 1 month, like it's a yearly thing. You get 1 month to create something, and you have a deadline. You will have to be done at the end of the month. Otherwise, you will get disqualified. So yeah, I think we're just gonna start up a little slow here. with some impressions. See, this was young, innocent me at the beginning of February with the first gray block out of the calendar that you've already seen. All of hopes and motivations and so many ideas. And well, as time went on, we added more features. You see, at some point we added the day numberings and the proper columns. And then that was when we had the first prototype of the menu sliding animation, when you switch between months working. At some point we added the side menu that you've already seen. The modal dialogue that guides you through everything. And yeah, this was pretty big a milestone actually. So this was the first time we actually had events displayed in the calendar UI. And that was shortly followed by this moment, which was the first time we actually managed to add an event. So this was like the full integration. We could actually create a calendar, add an event, and it would actually save, which was pretty exciting. Because this was the first moment the calendar was actually like functional, like the basic functionality of a calendar was given. Yeah, about that. It turns out the February actually only has 28 days. And you would think people working on a calendar are aware of that, but it really only started to hit like 2 days before the end. Yeah, you can imagine. Yeah, we had We had some fun with that. Wanna talk about the big one? Like 2 days before the deadline?
Oh, yeah. So we basically discovered all the events were gone, but only like when we went up, went to the past, then they were gone, but only every second page. It was like, whoa. So at the end we tracked it down. It wasn't very interesting bug. But that was on the last 2 days, and we basically had like a live copy that we were working on. So we either throw away everything we did, like until it's to a very old version, or we screwed. We made it somehow.
Yeah. At the end, everything actually worked out, and surprisingly enough, the entire thing is functional. But you might be thinking yourself, I mean, it's the entire month still, 28 days, right? So why would it take so long? Why can't you like make a plan at the beginning? And well, I guess this is the point where we'll have to talk about something. Feature creep. Yeah, this might be a concept that you aren't aware of. Basically, feature creep describes like you have a project and you have a basic scope defined and you know what you want to do, but then while you're working on it, you're like, oh, wouldn't it be cool if we add this feature? And oh no, we need to add this. That would be really fun. And then you just pile on more and more and more and more work on top of everything else. And then at some point you just like completely lose track of time and you realize, oh wow, we still have a long way to go and we don't even have our like core functionality working. So this is basically, don't worry if you can't read this, no, it's a bit small, but this was like the checklist that we created at the very beginning of the month. And basically during the month we continued to add to it and also check boxes. But I brought this out here so you can see like how much was actually planned and like how many of those boxes then actually turned out to be checked by the end of the month. We definitely learned valuable lessons there.
Yeah, but we definitely got our MVP done. Like the green part on the top. Hey, we have calendar.
Yeah, at some point we decided to really like focus in and see, okay, what is the minimum viable product that we need to be done by the end of the month? And then we decided, okay, everything else, even though we had some really cool other features that we were already working on, we said, okay, we need to put this on hold. We need to focus fully on getting the first, the actual thing working, and we did. So that was pretty amazing.
Yeah, we finished 1 hour before the deadline. 1 hour.
Yeah, like 1 hour.
And we were thinking about, okay, we still have 1 hour. What shall we do now? Oh, we need the tutorial video. Thankfully, we scrapped that. Otherwise, we would be very done.
Yeah. Okay, that was really the point where I was like, okay, no, we still have to save this world. We need to make sure everything is actually properly working. And the only thing we really ended up doing in that last and that last hour was taking a nice like 360-degree picture for the world preview. And then we submitted everything and we said, okay, forget about it. And 5 minutes after that, I realized the picture was the wrong way around. Yeah, I know, it's amazing. But yeah. So, since we know some of you, especially watching on Twitch, haven't really seen Neos before. So I think it's a really good idea to get started with a little introduction in what is actually possible in this environment that we're in.
Yeah, so we are in a virtual environment, not just alone, not just with Jack, but with many other people. And yeah, we don't just talk here like we currently do, we can also create stuff together. And also because we can work together on things, that means we can teach other people stuff and get feedback from them. It's kind of a nice cycle of creating and talking, and of course more. Also, since we're in a virtual environment, we have like all the space we need. So we can build our stuff, put it in a corner, and then we can build more stuff and do more stuff. At the end, we can build our own environment here and just have like the whole place is our workspace. And probably you who is the audience in the audience or people who are regularly in Neos, you know the pattern what happens. Like people build their stuff and over the hours like the windows pile up and you get more and more windows. So yeah, but at the end you created your own workspace, so nobody is understanding what you're doing, but you know, oh, that's my notes, that's what I'm working on, this is the thing that's actually getting out of it. And somewhere in a far corner of the map or of the world, you have like your inspirational picture wall, like it's getting bigger and bigger. We also had such a wall. We saw a few pictures of it. So yeah, that's Neos for you in a nutshell. But of course, we don't just create like random cubes like that. Like I'm very bad at art. But you can also do some programming, like this ball. This was also programmed in Neos. Speaking of the ball, it's up to you now.
Yay, caught it. Nice. Okay, so yeah, that's basically the general idea. And I like especially this pattern of whenever someone is working in the world and they start like just like 360-degree encapsulating themselves in their project. I think people attending have probably seen that before. It kind of happens every time. But yeah, so now before we continue, I want to give a bit of a disclaimer here. The rest of the talk is going to get fairly technical because we have like a pretty technical project that we were working on and we are both programmers and this is gonna be about programming. But fear not, we will do our best to like at least make sure that everyone is like familiar with the fundamentals of logic and try to explain everything in like simple terms to make sure everyone is up to speed and no one gets left behind. But yeah. With that said, this is Logix. This is Neos's built-in programming language, which is like a graph-based visual one, as opposed to like traditional text-based programming that you might like already be familiar with. And the basic idea, the basic principle here is that you usually have like a flow that's going from left to right. And we kind of differentiate between two types of flows. The one would be a control flow, which is like these white wires here represent that. They're called impulses. And just like in a traditional programming language, you can like choose how in what order your code executes stuff in, and you can branch off of that and make loops. And that's basically what this does. So if I like pulse this, you see now it triggers the false at the bottom. And if I switch this to true, now it goes at the top, so I can control like where the flow is going, basically. And this is more akin to like imperative programming styles, where you really like very like explicitly write your code in a way where like, okay, do this, then do that, and then like get to that end result by doing these steps. And the second type of flow we have is data flow, in this case represented by these blue wires, which are like numbers. And you see in this case we have a multiplication happening. We have an input 4, 8, it multiplies, we get 32. I think you will probably understand that. Which is kind of like a little reminiscent of declarative programming, I find, because you don't really care about how you get to the end result. You just write out your logic and it will just happen, and it will also evaluate in real time. So if I were to change one of these inputs, you should be able to see that it basically updates immediately. Let's get to the next one. A very simple example of a piece of code, and I have written out basically the equivalent of the same code in Python. And I want to very quickly show how you can compare logics to traditional languages. You see here, this is literally just a function that's checking if the number we give it is even. And it does so by getting the remainder of the number divided by 2. And if that's 0, then we have an even number. If it's not, then we have a false number. And we basically do the same here as well. So we have our input number 7. We do the modulo operation, which basically just divides and gets the remainder. And if that's equal to 0, then we get either false or true. And we can then use that to also control the flow of our program. So we have a more kind of declarative way of writing out the logic, how we check for if the number is even, and then we have an imperative style of using that result to control execution flow of whatever is happening after that in the program. Yeah, let's get a little bit more complex here. Calculating a triangle number, which is basically the triangle number of 1 is 1, of 2 is 1 plus 2, of 3 is 1 plus 2 plus 3, and so on and so forth. Here's a very helpful picture from Wikipedia. This gets a bit more interesting because now we actually introduce an intermediate state here. So in the Python code, you can see we have a variable n, which at the beginning we initialize to be 0. And then we do an iteration here, so a for loop, which goes basically as many times as we have specified, and every time it just increments n, and that once we are done, then it just returns that. And this is basically the same that's happening in the code here as well. So you can see this is basically just a loop in logics. At the beginning, we get one impulse that the loop has started, and then during the loop, it impulses as many times as we have specified. What's interesting here, though, is that even though we do set, on the beginning, we just set it to 0, and then on each iteration, we increase this. After the program is done, this value, the 55, is still going to persist. Because we don't really have, in Neos, everything is kind of always running. You don't really have a state of, okay, the program didn't run yet, or the program is done running. Which is why in some languages, you can just say, okay, I don't really need to give it an initial value. In logics, you probably should, because otherwise, your execution might be influenced by whatever happened in the previous execution. So going a notch up from that, calculating the Fibonacci sequence and returning it as a string. This is interesting because we once again have now two internal states. We have the number pair A and B. So Fibonacci is basically you just start with 0 and 1, add them together, add it to the end, and shift it all 1 over, and you do that as many times as you specify. And then we also have the string here, which is also going to be initialized to be just a string that's only contains a 0, because it will always start with a 0. And to show this is to show how different data types are represented in logics. So in this case, you can see here the green is basically just an integer number, and the green with a line through it here is two integer numbers together as a vector. And we do the same logics here, but the same logic here as in the Python code. So you see this entire green part here basically calculates the sequence. And then this red parts over here, which represents string variables, does the string concatenation. So you can basically see on a glance what the code is doing, and also what part is dealing with what data types. But okay, so now I have basically now shown you how Logix compares to traditional programming languages, just so some people that maybe know programming but don't know Neos get a fundamental idea. But the real question is, what can Logix do where real like traditional written programming wouldn't be such a good fit, at least in the case of Neos. So Logix is awesome because it's fully real time and it's embedded in the world. So you can just spawn out nodes here. I can make them bigger to make sure all of you can see it. I can spawn another node, can connect them, and without needing any external tools here, I can also just immediately like see, oh, what's the state of this variable during its execution, because it's all real time. And you see we basically have a number here that turns into a color. But it's not just that we can very quickly inspect the code we're writing. We can also just conjure up any object we want, like out of thin air, and we can, in real time once again, just take that object and connect it to the code that we've written. So you see here we have like an interface card of the material. I just take the color, which we have programmatically defined now, connect it to the color of the box, and now we have a rainbow box. And it's all real time, it's all cooperative basically, because you see me in the world while I'm on this. We all see it updating in real time, and this is like really the powerful thing of the like collaborative building environment Neos provides. Yeah, and I can definitely suggest everyone to give it a try if you're interested and haven't really had the chance. It definitely won't hurt. But now, still, we know that not everyone here is familiar with projects in Neos, like how they might unfold. So we kind of want to show a little example of how a project might start like simple and then continue on. And for those of you in the audience that have already been in Neos for a while and you have like worked on projects as well, you may be able to spot a few patterns that you recognize in there. So let's quickly clean up the mess I made here. And let's set the stage a little bit. So, okay, I'm building a nice hangout world so all my friends can come over and we can have a good time. But the issue is I'm not really that great at like making stuff interactive. So I go to my friend Autopilot and ask him to help me out. So, you know, you've seen the world we did, right? But it's like we have lots of rooms and they're connected by floors. But I'm not happy with that because I would like to have doors in there and I would like to like be able to actually open and close them. Do you think you can help me out with that?
Yeah, door, yeah. I can do something. Give me a moment. There, a door.
Ooh, that's pretty amazing.
Let me show you. You can just open the door. Here you go.
Ooh, nice. This is perfect. Nice. Thank you very much. I love it.
So, that's actually quite simple to make. You, of course, need some kind of model. Box will suffice, but you can do more like this. And then you add a single component. I forgot the name. I think it was a joint component. And then you can just grab the door and it goes around the hinge. Yeah, simple door.
Okay, so about the grabbing part, actually, I was thinking because we are like in a virtual environment, right? And I'm like, it's like, why do I need to touch it? So my question: can you like maybe come up with something so the door like opens automatically whenever I get close to it?
Okay, so door for the lazy. Yeah, we can do that. But to be lazy, you need to program something. So yeah, there you go. Some logics. And your door, just go close. It will open.
Oh, nice. Thank you. Exactly what I wanted. I love it.
Nice. Nice to make people happy. So, just a short explanation here. There's basically a box there that you can collide with. And whenever you collide with it, the logics here triggers. And there's this timer. Basically, whenever this timer has been freshly reset, the door will be open. This means as long as you're in the box, the door stays open. When you leave the box, you have 1 second, then the door is closed. That's the code.
I have a problem. So I love it, but the issue is now that the door opens automatically whenever anyone comes close to it, like everyone thinks they're invited, but honestly they aren't. Like I also need some time for myself. So do you think you could like maybe expand on that and help me build like a lock or something so I can like lock it if I don't want other people to come inside?
So you need private space. I see. Yeah, then let's add a lock to it. Yeah. Yeah, like a key is probably fine for you. There you go. Now you need a key to
Ooh.
enter.
Nice. I like this key. So I just put it in and the door opens. Perfect. Exactly what I need. Thank you. I love it.
Yeah, so actually I should maybe point more to it. So yeah, we now have this code here, and basically this area here has been added, which is just checking if the right key has been put into the hole, and if yes, we switch it to be unlocked, and that will be combined with the timer that was already there, and then opens the door. Small addition, but now it's automatic and lockable.
I lost the key. So the issue, if I don't have the key on me, I still need to be able to go inside. So I need like an alternative to the key as well. Do you think you could maybe add a keypad? So like I can also just type in a code if I don't have the key on me to open the door?
So you just lost the key and you think you can remember the code? I would do it
sure.
anyway. I would do it. Okay, fine. So there you go. Yeah, now you have your keypad. I put in a very secure code there. You have to figure it out. Give it a try.
Okay, I'm gonna see. 1, 2, 3, 4.
Oh, you guessed it. Oh my.
Nice. I love it. Thank you very much. This is gonna help me out a lot. I love it.
Goodbye. Oh yeah, so the explanation, of course. So now we added this code here, which is for the keypad. So basically, whenever a key has been hit, we will just put like a text together that combines all key presses. Unless we have the fourth digit already, then we just use that opportunity to start from scratch. So at the end, we have our combined key that we put in. We compare it to the very secret key here. And if it's the right one, we will unlock the door. Simple addition.
Everyone loves it. I showed it to all of my friends, and actually I have like 6 people that want to have the door installed as well. The issue is Sarah doesn't like the keypad, and Josh actually asked if he can only have the keypad because he lives on a space station. Do you think that would be more fitting? Do you think you can do that for them?
Oh, give me a break. Stop. No. This is a mess. No. It doesn't look like it. This code, it looks so clean. It's like you have a city chart here of subways or whatever, but it's actually a messy code already. So the problem here is now we start to not only have a single door, but we may have many more doors, all with extra wishes and stuff you remove. And one problem, for example, with Logic's code that can be problematic if you do it the wrong way are those arrows here, those reference arrows. So because this arrow here is so this arrow here may be pointing to something like the keypad, for example, but it's not part of the door. So when you delete the keypad, this ref arrow will not work anymore. And then you may add a new keypad, or you may undo, but chances are that this is still not working anymore. And you're wondering why your code is broken. The biggest reason here is this code is not part of the keypad or the lock, but actually part of the door. So we should split out our code and make sure every piece is in the right spot. And also make sure that we have it split out in the proper pieces. So, for example, the actual keypad is actually the code here on the bottom. So that should be its own piece. Then we have the lock. That should be its own thing. Then we have like the timer. Now you would think I would just make it one piece. But actually, what happens if you have like a button to open your door? This could be like for some space station. You maybe want to have like one side a sensor, other side a button. Could happen. You don't want to accidentally expose yourself to space. So maybe the trigger for the door opening also has to be a separate piece from the actual like waiting circuit. And then, of course, you have the door itself. You can have different styles of door, like the space station with its double-sided sliding door compared to a more traditional door like here. So you have many separate pieces, and you somehow want to keep them working together. But on the other hand, they are separate pieces. So what do? That's part of the next step. So let's go to the next slide. And let's make sure my doodles are gone. There you go. So now I'm over here. So one of the ways you can split the state of your object is using dynamic variables. So basically, dynamic variables you can just put in your hierarchy. Actually, I have to draw here. So you can just put them in a hierarchy and just give them a name. Okay, technical issue, but it's fine. So you just give them a name, and then you can reference them from afar or from within the hierarchy, and they automatically connect. So you can have variables on objects that you put in place, and then it is known to everyone else, to the neighbors, to the parents. Everyone knows that they are there and what they do and what they want from you. Like whenever you do a family visit, it's always the same. Like here in this example, we have this box here. And when I put this box on red print, you see that it's announcing its existence through a dynamic variable. Yukilob, I stole your dynamic variable space. I'm sorry. So it's announcing its existence, and we can use that again to do something with the object. Let's actually get it back up here. We want to have more fun with another cube. Yeah, so we can also just access this object and remotely control it, like give it a different color, like putting another object in and give this one a new color. So these were two separate objects, but depending on which object I put in this hierarchy here, it was talking to a different object, this code here. So this is one way to make a code more modular. And it's always good to use the hierarchy of Neos to advantage instead of having all those reference arrows, interface cards everywhere. Like they have their place, but it's more short range, like in a small thing. In the bigger things, try to modelize a bit more, and then you can more easily replace your code, for example. So next step is there's something called dynamic impulses. So one thing were the values, like you saw with the blue lines in Logic's code in the beginning, but we also have something for the white lines, the impulse lines, to be disconnected but still be together. So here we have dynamic impulses. So they are basically like when you have when you do like a radio communication, you have like a sender and a receiver. And then you have a frequency you're talking with. That frequency is actually this so-called tag. So only when you use the same tag, you can actually communicate with each other. And also, which is not like real life, you actually can specify which area you want to cover. Like, do you want to broadcast the whole world using root, or do you just want to have a very specific receiver that you want to target? So I will now press this top button there, and you will see that those two nodes here received an impulse. I can also just target this single node here, and you will see only the bottom one got an impulse. So that's basically it at the beginning, but we can do more. So this example here is showing a different variation of a dynamic impulse receiver, or with dynamic impulses, because they are not just like a trigger of something, they can also contain a single value. And you can use that to your advantage. So imagine you have a user interface, like actually you already saw an example. You remember the keypad? It had 9 buttons, one for each number. But we didn't have 9 different paths of code to handle all those numbers separately. Instead, we had a single dynamic impulse receiver. So basically like those buttons here. Those buttons are not connected in any way, except they are in the hierarchy. And I do some dynamic variable magic to make them recognize that there should be a receiver here in this area. So when I hit this button here, it will send an impulse through this one here. Together with the information, I have been pressed, I am number 1. So number 1 comes in. We have the original value of 0 here, times 10, still 0, plus the number we just got is 1. So when I press 2, we just do the same calculation, and at the end it's just adding a number on the back. So it's basically just 1, 2, 3, 3, 3, and so on. It's just a simple number input at the end. And we also have a clear button. But yeah, this way you can exchange your UI to maybe a different version. You have maybe a very talented UI guy that is able to do like nice things, not like me, like the gray boxes. And then on the other hand, you have somebody doing lots of logics, and you can work on things separately. And then at some point you meet together, you throw stuff together, and the dynamic variables and dynamic impulses, they just make sure that everything is really working together. Definitely worth trying out. Takes a bit of time to get into, but it's definitely worth it. Now, here is like why we had warning technical, basically. Because this is quite a complex example. So if you're more familiar to logics, you may recognize there's a bunch of stuff going on. So I will try my best to walk through. So those of you who don't know logics but regular programming, this is basically like a callback, higher order function. So what we do here, it is step by step, is we have a dynamic impulse. So we trigger through the hierarchy an event. But we attach a value to it, and that value is not just like a number. It is a slot, an object in the world hierarchy. And that slot has been prepared with dynamic variables. So we attach to this object multiple values, and those are, for those who know the programming terms, arguments, but they can also be return values. So we feed values in, and we get values out with a single remote call to some other place. So in regular programming, you would call that a library. Or at least you have some module of code that you're calling. So also, what we can do with that, because we can target our impulse receivers to a slot in a hierarchy, we can also specify something that would be more like a function pointer, function reference in programming languages. So we, just by some convention, we specify the tag of whatever we put in there as a function reference to be, let's say, callback. And so that would be basically, this would be our callback here on the bottom. So it's just receiving a simple value and displaying it. We will see this running in a second. So this will be our target for whatever that code here is doing. So first we set it up, tell it, yeah, please, when you do your thing, like let's say you go through the database of calendar events. Whenever you have a calendar event, please tell me each day that there is for this event. And then you just so you tell then this code here will be called for each calendar event, but not only a single time, but for each day. So the idea was to fill this whole view with events, because you see you have the MMC event, which goes a long time, multiple days, and that will be this adding of events will be handled by a similar code like this. So we set it up with information, then we trigger it. Then this code does our complex database. Then this code here does its complex database operation. And then this one here gives us the output. Or in this case, it's very simple stuff. It's basically just an extravagant for loop. It doesn't do more. So sorry for the complexity here. But it's trying to keep it simple. So it's not a thing you set up like for everything, but if you have a complex code, you do like some processing of JSON. Yeah, that's actually a good way to throw the ball. Yeah, I know you want to talk something. Oh yeah, forgot the ball there. Here you go.
I can do it. Yes, I got it.
That was a good throw.
Nice. Yeah, so what I want to show you next, oops, that was one too far, is basically how we use this callback like syntax basically that we more or less came up with. At least we haven't seen anyone else use it in this way before. To talk to the parser that basically does all the parsing. So I'm going to get a bit more in depth with the data structure, but basically all of our calendars are stored in a single string of like 4,000 characters of length. And to turn that string, which is just text, into like all the information we need to like deserialize it. We wrote code that does that, but it's the issue is with that's like 300 nodes that handle the deserialization of that, which is pretty amazing because we actually use it in like multiple places or in the calendar. But we only really have this code once. So how we set this up was we just use exactly that. We give it a callback. So I'm going to try to explain this in simple terms here, although I can't because we forgot to put a collider on this red print, which is amazing.
Yeah, preparations.
It's fine. Yeah, it's not like we worked a week on this. But yeah, I can explain it anyway. So basically the idea is just we like have the parser slot, which we just have in a variable. And then whenever we need it, like in this case, it would be this impulse when I click it. What it will do is it will first configure the parser. So it's going to basically set a bunch of variables that are just on the parser, which control its execution. And once this actually does execute, like one of these variables is actually just a callback, which like that code, like the parser itself will call once it's done parsing. And if I quickly click this, you will be able to see that now this actually is connected to the calendar behind there. So it's actually like working with live information. Once we call the parser, it's going to give us a callback, which will then just take that like data we have. In this case, it was actually serialization, not deserialization. But it's like just the other way around, and we just write that into a string, which we can then store, for example, to the cloud variable. The interesting part here, however, is so to keep performance optimized, because the calendar, like the parsing operation works really well. We had a pretty good code that does it. The issue was like if you had a 4,000 character string and like if you like deserializing it would actually create more than 4,000 slots at once. So that was actually, well, not more than 4,000 slots at once, but like for each node in there, basically it would just create one slot. And that would like start to lag if the string got too. What we had to do was we had to figure out, okay, instead of just doing it all in one update, we just only processed 50 characters at a time, which we just measured was basically no performance impact at all. And then on the next update, we do the next 50 characters until we are done with parsing the string. And that worked. But now you might, like, if you've already worked with programming in the past, you might see a little issue arising here, which is we have multiple parts in our code where this parser is called, and the parser doesn't update, it doesn't finish immediately. So what do we get? We get basically non-deterministic execution time. Which means if we were actually to call the parser from one part of the code where, while it was still running, we would kind of corrupt its internal state because we would change these variables which control its internal execution, and that wouldn't be good. So yeah, I personally didn't really think before we started this project that I would ever have to worry about race conditions and logics. But I do. So we literally invented a locking system here, which is kind of similar to how Wi-Fi like detects collisions. We just, before we start the code, it's just going to say, hey, can I get the lock? And if the lock is already taken by another piece of code, it's like, no, try again in a second. And it does that until it actually does get the lock, and then it like has a couple of updates reserved to actually prepare everything. Then it will execute, and this way we make sure that like the calendar isn't like interfering with itself, basically. But yeah, since we were already good at the ball throwing part, I would say we take a deeper look at the data structure, and I'm going to try to throw that ball back to you.
Yeah, I got it.
Nice.
Thank you. So, My part is more about the data that we store. Yeah, why is data so important? Well, it's actually like maybe it's written somewhere, but I haven't read that much in that detail yet. But it's probably the rule is number 0 in development, because before you do any coding, you better should ask yourself, what information do I need actually, and how do I store it? Like, if you store it in a weird way, you're setting yourself lots of obstacles in your way. And if you do something very hidden, maybe you see those obstacles when you're almost finished with your project, and now you have to rework all your data and have to change all your code to accommodate this change. So it's always good to think about your data and your data structures. How do you store things? Where do you store things? And for us, the most important part was it's a calendar. So it's not something that you spawn and delete and be happy with it. There should be something that persists, like forever, hopefully. There's 2 ways we can do that here in Neos without resorting to external services. So one is just to have an object that you can persist, that you can just save. So basically just open context menu, save it. This is quite good for many things, like when you play a game, when you're done with it, and yeah, let's save that. Perfect. But our calendar, it's supposed to live on your dashboard. You don't really spawn that much stuff into your user space where the dashboard lives in. And even less you save stuff that's in there. So it's not really a thing that you just grab a thing and you save. Also, you can't really trigger saving objects from logics. Would be nice, but maybe your storage would be full very soon with some crazy logics. You never know. So what we instead use is so-called cloud variables, where we can't really show much because you just enter like a bot command in a chat, which we actually help you with. So you don't have to remember the command. You just go through the step-by-step procedure and you get the commands you have to write. But once you have that variable set up, you can just use it with logics. And you can basically have those 4,000 something characters of text and save it and retrieve it. This synchronization is something a bit out of reach from us. So in theory, if 2 people at the same time write to it, very likely you get either one of those only winning and not one writing, then the other reading and putting a modification in. So there's still the issue of race conditions, who wins with his value. So group calendars are still out of reach. But at least you can use dynamic variables, like they have a permission system that we basically can just use for free because it's already there. So you can share calendars and you can give a calendar basically with group access to people. Just make sure not 2 people at the same time write to it. So there is actually functionality in Neos to have private calendars, to have public calendars, just using those cloud variables. What did you store in there? As we already hinted at, text. And well, there's actually 2 ways to encode information. Like you can either use like human readable text, or you can use binary information. Binary is of course better for the computer and it's much more compact. So even with the limited space, wouldn't that be advantages? Wouldn't that be an advantage? Yes, it would be. But also it may be harder to get the information out. And if you change the data format, usually there's no extra information like what is the content. This is why it's very much smaller to have a binary format, because you just write some bytes and bits and you're good. And like the first thing maybe your date, the second thing maybe like an indication that there's text. But at the end, when you change a thing there, the whole thing cannot be read with the same code anymore. So the text-based format like JSON that we're using, that is more resistant because it always has those descriptions, what is stored here. But of course, JSON also is a complication to parse that. You saw the tiny code that Jack had there? Like, it is tiny compared to the parser actually reading the code, that JSON. So it's still a complication. So one simplification we did is actually we only use those objects which you see with the curly braces here. So we can read and write those objects and string values. So everything else like numbers or truth values, those things we intentionally ignored. We don't even, it would probably just be an error in our code. Instead, we just made sure when there's like a string, like a text value, we just decode it after the fact. So we had a bit more work when working with the translated data. And what did we actually translate it to? So it is translated to an object structure. And that's actually something that Yukilop invented. Yukilop was actually also part in our team. It is, well, the competition is over, so not sure which tense here. But so basically, we translated it to object hierarchy, the JSON structure. So we have basically here, this is a calendar. Or maybe I should use this here. Ah, yeah, I can write on inspector. Yeah. Okay. So we have this object structure here. And you see that we have like meta information, like a name of a calendar, description, when was it, is it edited, is it visible, can we edit it, or is it a read-only calendar? But also we have a list of events here. Those events have a unique ID, so we can identify them later on quite easily. And they have also their own fields. So you can see this structure here very strongly corresponds to the text that you see here. Because it's basically generated from the JSON, and also it generates the JSON. Some things, like the color here, they are encoded in a way that it's a bit more compressed. You know, we could use like 3 different floating point numbers with all the decimals behind them, but usually you only use a very limited amount of colors. So here we shorten it down to just 3 characters. Another thing very heavily compressed, here are the dates. The dates, so this is actually both dates, start and end date of a calendar event. We just used 4 characters here. It looks like 2, but those are like Unicode specialties. So there are actually 4 characters here that we use to encode start and end date. It's in a binary format. So here we compromised a bit with the readability, because a proper date in a human readable format would be like 12 characters, and you do that 2 times for each calendar event. That adds up very quickly, and we were still limited in characters for the calendar. So this is basically a good seg to our last piece. So at the end, oh wait, one thing I was missing. So there is, like, we have the dynamic variables here. I could get an inspector out. So we have our variables here with the values, but they are all text. Some things need to be translated. For example, the color should be translated to a proper color value that we can use in UI. And that is done using something we just plug in, like similar to the dynamic variable demo I did a few minutes ago. We just had pieces of code that we could just duplicate and put into the color variable, and it's into the color part of the hierarchy. And then it would read that value. It is a dynamic variable. You can read it with logics, and it would read that value and drive another dynamic variable, which is now a color. And this we could then later on use in our UI. So one thing that we had to do is, like, we basically recreated a small database here, but that also means we have to search the data. We have a calendar. We are in February. Well, now we are in April. So when we want to get all the events in April, we have to go through all our data and see, like, what is overlapping with April. So there may be events that are just in February, like MMC, but this talk is in April, so we should get information out of that and put it on the calendar. For that, we added another data structure, which we call the index, which is just basically whenever there has been changes to this, it will update. And we actually, what Jack didn't mention about the parser, it's actually when you did like if you change the date in the JSON, it's actually just changing the variable value in our structure here, in our ensign structure. So we are not clearing everything and then creating it from scratch. We're actually doing updates there. This means we can now take a reference, like imagine this reference arrows I talked about, that they are evil. Well, we basically do the same, just putting it into a nice variable. We're taking it out and putting it into the next piece of code. But we do that through our logics, and we know this part will not be edited, will not be deleted on a whim, but only when our logics wants it. So now we have some more proper references here, and use that to have all our events sorted by whenever they start and end. And this can be used to just go through and then start getting all the values and pushed it on to our UI. Which takes us to the next point. So we have all the invisible things which are hard to show in a presentation. And now we want to make it visible. So there's like what you can do to make something visible is basically whenever you change something, you have some code. Like imagine the white impulse wires that do like an action, an event, like step-by-step instructions. You can have those kind of stuff, and basically you change something. Now you have to update the UI. And let's get actually back to the calendar. Like we changed the color of the calendar. Let's take demo calendar 1. You may want to focus the camera on the calendar. This is basically non-scripted now. So we have the color of the calendar, and we just change it. And now this code needs to tell some other piece of code, hey, we have changed the calendar color. Now please go through the whole calendar and change it there. There would be lots of manual updates. It is possible, you can set it up, but you have to set it up. You have to write the code. It's easy to miss like one change. Like you change the text and suddenly you notice, oh, the text is not updated. I forgot that part, but the color works. So to avoid that, we basically use something that is called data binding, which is basically telling some smart library or framework like Neos, please take care of that. I don't want to think about it. Let's just make sure that those two values are connected. So for example, here on that red print, we have two text fields. And we have them linked. So we use the trick with dynamic variables here, but there's also other tricks like with value copy and write back, or listening to changes and writing manually. There's many ways to do that. But here we used a bridge of dynamic variables, which are actually referencing the content of those text fields. And when I type in one of those, it automatically updates in the other. But this is not like a single drive where you just have one input, one output. Here you go to the other, and it also works the other direction. So we can change the data in our calendar, or we can change whatever we type in the UI, and it will change our data. So we didn't have to do much code that does back and forth communication. Which was very nice because otherwise we wouldn't have made like the last few days with this. So one final demonstration here. This is basically when you click on so when you go on the calendar and you go to editing and you click on an event, you can now edit things and it will just work. So this piece here is basically a demonstration of that. So we have our user interface here, or maybe let's put that so that's easier in the camera up there. So we have our user interface here. We can just change the value. And then we can just click on a button here to bind to a different value. So what we're just doing here is we basically just get a reference. So here we are working with fields to the variable itself. So the setup here is a bit complicated to explain. So if you aren't that deep in there, you can ignore it for a minute. I try to keep it short. So basically we have our variable here with the actual value. And then we have another variable, which is a field to that value. So we have, and instead of reading and writing with the primary variable, we use that with the field and use that to link the two pieces together. So that's basically the trick behind it. And if you set it up properly, like in the right order of things, and you change the way you link those things, it will update the UI. So when you change the link, it will update the UI, but when you change the value, it will update in both directions. Yeah, so that's basically the trick here, how we removed lots of code, or actually avoided programming lots of code with the connection between the UI and the other pieces. Dynamic imports were also a big thing. So basically, when we wanted to remove a calendar item in there, instead of going through the calendar again and searching where are they, we basically did a broadcast, hey, calendar event MMC23, you're over, go away. And then it would basically, all receivers would see, oh, that's my name. Okay, I will go back. I will destroy myself. Calendar was cleared. So some tricks were there to make life easy. Yeah, so that's basically the end of the scripted part of this talk, and it was longer than I expected. Look at that. We have some hidden stuff here, like a timer that nobody can see.
Yeah. But yeah, that's pretty much like just a brief introduction of all the stuff that we went through within this month, which was like a lot of fun, and we honestly learned a lot of things and came up with a lot of techniques that we haven't really seen anyone else use yet. And this won't be the end of the calendar. Like, this is a first working version, but we definitely we still have that long list of unchecked boxes, and we still do want to finish adding more features. So there will be updates in the future for sure. You can just save the public folder of the calendar. I can give it out after the talk if you want, and then whenever we do publish new versions, we will both announce it on the Discord probably, and also just push it into the folder so you can update it. And because of our data structure and cloud value storage, all your user settings when you update should, unless I mess something in the coding for that up, just should, yeah, big asterisks there. But basically all the user settings, like what colors you choose for the calendars, what calendars you subscribe to, that should all just automatically reappear on the new version, so you don't have to worry about losing anything. I'll definitely make sure to test that extensively though after making such a claim. But yeah, that's pretty much all from it. So thank you all very much for attending. It's honestly a blast seeing so many people showing up to such a technical talk. But it was a lot of fun with you all.
Awesome, guys. That was really, really thorough. Actually, let me put myself on shout so you can hear me. Great.
Mm-hmm.
That was really, really thorough. As somebody who only kind of knows the basics of programming and logics, it was extremely clear what you guys were doing, at least to me. We're going to open this up to Q&A. So I would love to have a question from the audience if we've got anybody. If not, I can try to open it up with a question. Raise your hands nice and high if you have a question. No? Okay, so I'll start with one and then you guys can keep thinking. Okay? And remember, we're doing this by this ball thing. So you're going to get, if you get to ask a question, you get one of these balls thrown at you, and it's a lot of fun. So I highly recommend asking a question. We're going to have a great time here. So what's the next thing? You had that checklist of things to do on the calendar. So what is the next thing? What's the next thing on the priority list?
Yeah, okay, I'm not going to toss you the ball. So we have a bunch of things still planned. The first update will probably not add too much fancy new stuff, and we will most likely just performance, increase reliability, make sure that, because You saw how the calendar looked 2 days before the deadline. There's a lot of like the logic's equivalent of duct tape holding that thing together. So we're definitely gonna do a bunch of refactoring to make sure this is all gonna be clean for the next update, and it should definitely behave a lot nicer. Although not gonna lie, like there's very few bugs that I have noticed so far. I'm like really impressed that this thing even works at all. Honestly, you should have seen it 5 days before the deadline.
Yeah.
Yeah, but after the performance updates are done, I think one of the biggest major features that will be added next to just showing more detail, and there's 2 things that I think will be very important. The one thing is sharing calendar. Currently, if you want to share your calendar with your friend, you would go to the settings, copy the link of the calendar, and you would just send that text basically to someone else, and then that other person can just go like add a calendar, subscribe to existing, and enter the link there. But this entire link handling and like copying, pasting, it's not really intuitive in VR. We have a concept for that we've pretty much already did the proof of concept, so we know it is going to work. We just need to actually implement it, which is our idea. We want to be able to, you click a button in the calendar in your dash, and it will actually just spawn out an object in the world, which is basically just contains that link, and you can just hand it to someone else. They can click on that thing, and then it asks them in their dash if they have the calendar installed, hey, do you want to add this calendar? So basically removing a lot of friction in the sharing process. And the second most important thing I think that we want to add is more metadata to the actual events, the most important of which being session links. So you can actually just, if you host an event and that event is live 5 minutes before it starts, you could just you could just edit the actual event, drop a session link in there, and then everyone who has the calendar can also just join your session through the calendar by clicking on it, which is also something that we definitely want to get working as well.
Cool. Do we have any questions in the audience? If not, there's sort of a question on. There we go.
There's a question.
Yes, go right ahead. Remember to put yourself in shout.
Oh, wait, I'm bad thrower today. But there goes your bounce. Hey, second chance. Use the laser. Lose your laser.
There we go.
Got it. Okay, so I'm not so familiar with shout mode.
Yeah.
Shout
I'm
mode,
not
please.
so familiar with creating UIs in Neos other than the funny orange slanted buttons. So Did you guys use UIX to make this?
Yes.
Okay, cool.
A lot of it.
I've not looked into it before, but this looks really nice. It's
Yeah.
cool. It's cool what you can do with that.
Yeah, UIX. UIX has a tiny bit of bugs you need to work around with. One of those hit us very hard before the end of the competition, which may actually be a new bug. I have to look into that. But if you don't have that, so UIX is a bit different compared to other UI frameworks I've personally worked with, because it uses the same component-based architecture of Neos. So things that are all-in-one solutions in regular UI framework, you have a button, and that button actually has included text, and it has a certain layouting behavior, and all those things combined. That would be a normal framework, how I know it from Java or other languages. But here in Neos, all those properties, being at a certain position, is a different component to the button that you can interact with. And then you have a text that's actually another component, the visuals of a button are completely separate from the button component itself. And then it also goes you have a few components that allow you to have so-called button actions. So usually in a regular programming environment, you would really quickly leave the UI area and add some random code snippet in there to do a certain action. And here we have a good amount of preset components cycling through a value, or switching a value, or triggering a dynamic impulse, which was used for the buttons on the keypad here in the example. So you can have lots of different actions, and some of them are quite powerful. And for example, one of those actions is actually starting editing a text, which is hidden under the name text field. It's just a normal text field, but in fact it's just a reaction to a button. So again, when you compose something like a text field, you basically have a position for it, you have a visual for it, which is mostly just a white image or something. Then you have the button, and the button itself calls the text field, which starts the text editor on the text. Is a separate thing again.
Oh, wow.
So usually when you spawn like the most complex component in UIX, that kind of spawns itself, like all the components. So it's usually not that complicated. It takes some time getting used to it, but on the other hand, it's much more flexible. You can create custom UI elements, just composing stuff together, like getting a custom checkbox thingy or like some reactions to that. It is definitely something worth looking into. But it's also a learning curve, so I wouldn't say that UX is easy, but it's quite powerful.
Yeah.
Okay. I'll have to look into that sometime.
Yeah. And maybe a little something about the design part of the UI. So what I actually just quickly brought out here, this was actually just the thing that I created before. Like we just had, you saw in the pictures earlier, we just had it all boxed out, gray box. It wasn't really looking nice. So like when I came up with the design, what I did and what I can actually suggest everyone else to do as well, I just like thought about, okay, what are all the UI elements I'm going to need? And then I just made like a little reference card that only contains these UI elements. I see how they work together, how they look when the inputs are disabled, for example. Like make sure you can interact with them, change stuff, just to get like this reference, which then once you have everything like how you like it, you have the colors, which I really tweaked for like an entire day until I was happy with all the shades, which is interesting because it's all gray, but like this was I can suggest everyone basically trying to do something like this that helps out a lot, and because once you have this, you can literally just like copy paste your UI elements from there.
Great. Throwing the ball
Great
back.
question.
Or should I throw it to the next?
Yeah,
Just
who's
with the
got
question.
a question?
there, Sizer, Sizer.
Zizzle,
Here it comes.
all the way across.
Okay.
Oh no, it's all behind you.
Wait, I'm gonna quickly
slowly.
help you. Like, oh well, I guess now we have two balls. There you go.
Oh, no.
I hope this one should actually work. Yes, the spotlight works again. Nice.
Got him. Lovely. Thanks for the talk, guys. And I really appreciated that last piece of advice, Jack, because I have done a fair amount of UIX and I have not tried putting together a reference card before, and I really like the idea, so I'll probably do that in the future. Yeah, nice idea. The one thing I didn't quite catch was, I think the last piece of dynamic variable wizardry you were showing off, where you had, I think, a dynamic string field going on.
Yeah.
Do you mind just going back to that? I wasn't quite sure what that was doing there.
So in like very simple terms, I want to say, so we don't just have a variable for the actual data, but we also have a second variable that just keeps a reference to where that data is stored, to what field we have the data stored in.
Right.
And the way, I guess I can quickly go back to the other slide there. I hope it's fine if I take over.
Yeah, it's fine. It's fine.
Like the way this basically works is we don't really change the value itself. We just like write like on the UI that just has a field and also a variable, and we just write effectively where that data should be stored. So we don't actually write the new data into it. The new location into it. And once we do that, this will actually, or it should at least, yeah, if I can actually click the button, this will like automatically update the field on here because the one that was just linked has priority. So basically what we're doing is we're just having one UI element with like one field and one like place where we actually input the data, and instead of just having logics to copy the data back and forth, we're just using logics to mount this UI to a specific part in our data structure. So in the calendar itself, we actually only have like one main hierarchy where all of our like deserialized Anson data is in, and every UI element basically just references that, which means that like we don't have like for every calendar we have like settings menu for every calendar. We just have one settings menu, right? But if you once you click the button, what actually happens is that reference changes. So like the UI of the settings menu basically just gets mounted to the data of of a different calendar. So we have just one menu, and it can just be reused for like n amounts of calendars that we store there without any additional complexity in terms of code.
Okay, I think I understand now. Yeah, we must have a chat afterwards. I quite like that pattern. I'd be interested to noodle with it a little bit. Thanks.
Yeah, sure, no worries.
It's quite rewarding to see just things being connected magically. Like it's when did we start doing that? I think like a week before the end, didn't we?
Yeah, we were just experimenting with different ways. The thing is, like the entire this is a project, and we kind of designed it in a way where it could actually be scalable and maintainable, and it wouldn't be scalable or maintainable if we just had like all the calendar code like duplicated in 5 different places and stuff, and all the like for each variable or for each calendar we just basically of logics that handles the settings or something like that. So we really like our main focus was on figuring out how to make this work, how to make this scalable, and how to make it modular. So we came kind of up with our callback system, which then had the side effect of us also having to come up with a locking system because yay, race conditions.
Over-engineering is also a thing, yeah.
I mean, we basically over-engineered this entire presentation.
Oh, yeah.
Like, we weren't just rehearsing for a week. We were just building all the tools that we were using here to show the logics on the screen, to have, like, the ball appear and disappear, to have the spotlight follow it.
The remote to change the slides. It's like...
Yeah,
you guys are certainly bringing a new level to the presentation game. I mean, it's NeosVR, the Edgy room here. It's like it has so many more capabilities than just being a regular slideshow presentation, and so we really appreciate it. I was really fascinated by the fact that you guys had the logics and it was interactable up on the screen, and I was like really blown away by that. Did you guys build that, or was that a pre-existing tool?
No, we made that like...
That's incredible.
Yes, actually today.
You made it today? Wow, I'm really impressed.
Okay, yes, so the backstory to the video screen, that is not visible at the moment. So the backstory to the video screen was, originally, it was just a quick thing. We basically asked Sisal, hey, you've got your camera switcher tool, which you don't see because it's over there and invisible for you. So you've got your camera switcher tool. Can we get like a live video feed from that and just display it to the others so we can basically show them the logics a bit closer up, because in VR resolution isn't perfect. So looking that far away to tiny texts, not a thing. So that was a quick prototype. Which was then a bit escalated because actually for us it would be over there, and for you it's over there. Then at some point we found out that's what the Switch stream is looking at, what Zeiser's camera switcher is doing up there. That's actually not perfect because it's usually a bit wider shot, so you see some surrounding area. Jack had the opportunity to invent a completely new system from scratch in a short amount of time, and then was placing dozens of camera positions around to make sure it actually works properly.
Yeah. It's also the beautiful thing of if you make your things modular, you can just make everything interoperable. Like we started off by just making the slideshow system so we can toggle through that, and then we also made buttons so we can define like what can the camera operator see, what can we see, what can the audience see, and we just like had variables for that, and we just built it into everything. Then we made like texts that we can edit that like basically just use the slideshow system to give us like talking points. Like, sorry to break the smoke and mirrors, but I'm really bad at remembering stuff. I actually have text that you can't see.
You just saw it, didn't you? Oh, no, it's not. Because you can't see it.
No, see it.
Yeah, right, even when grabbing. But if you want, we could actually invite you now, unless there's any other question from Twitch or something. Yeah.
I think we're having a slight technical issue.
Oh.
But Rampa says Jack is silent. Rampa's the one
that is moderating our Twitch stream. So there's something going on.
I wasn't in shout. I'm sorry.
Oh, okay.
I feel bad.
There you go. No, it's fine. We always forget to do shout mode. I did it at the very beginning of the show. So
yeah,
it happens.
So fun story. We actually wanted to make it so that when you're holding the ball, you are automatically in shout mode. There is a component for that, but that component broke in like a recent update to Neos. So yeah, that's another one for the GitHub.
Yeah, I still have to report the bugs. Yeah, you remind me on my to-do list.
Okay.
But yeah. Yeah, I think, do we have any other questions from the audience?
Yeah.
Go ahead. Wait, let's get one of those balls. Let's do this.
There you go. Catch the ball.
Oh.
No!
Oh no!
Oh, there you go.
Yeah, thanks. I was just wondering, all the fun assets, examples of logics and whatnot you used during your presentation, which was great, by the way. If that's like available somewhere, because that's, I think, a great learning tool for people who are trying to learn logics and whatnot.
Well, I mean, for once, the entire recording here will just be available on YouTube after we're done. But I can just toss this all into a public folder if you want, and I'm gonna give that out after the talk or I'm just gonna post an announcement on the MMC channel on the Discord so everyone can see. So that's a very good question. We're gonna put all our code snippets in there.
Yeah, that was great. It was like a Logics Crash Course 101 kind of thing. 101 to...
Yeah, we tried...
It got a little bit... It was quite clear, though, so I really appreciate that.
Nice. Yeah, it's a bit difficult if you have multiple people with different levels of knowledge attending in your talk, and you are trying to you don't want to explain everything in detail because then the people that already know it will get bored, but you also can't just skip over everything because then the people that don't know everything won't be able to follow. So it's fun.
I think you guys did a fantastic job.
Yeah.
We did a lot of work on balancing that out. Yeah, we were critiquing each other's talking points, doing lots of tests. Yeah, we had like a week.
I think you have some feedback going on there, so if you could mute your microphone, that would be perfect. Thank you very much.
Great. Do we have any more questions in the audience? There was one question in the chat, but I believe it got answered, and I think that you guys kind of answered it, and it was about cloud variables. I can just read it, and if you guys have anything to add. Let's see. Two-way data manipulation, is the dynamic part of the variables built in, or is that custom built? And then Rampa said dynamic variables are two-way. You just need to use separate built-in read and write nodes. Cloud variables are very similar to dynamic. They're just stored in the cloud where you can actively access them from anywhere. Yeah. Do you want to add anything to that?
Yeah, I can actually add to that because you can use the logics nodes to read and write dynamic variables. But to get the two-way communication, you don't really need that. There's also a thing that's called a dynamic field. So you can just basically turn any field in your entire system that might store a value into a dynamic variable. And if you use the same name there as you would use on another field or on another dynamic variable, then just Neos itself, the Froox engine in the background, just make sure that all of these are kept in sync, which is really handy because if you don't do that and you manually create all of your linking between variables writes here, reads there, then you are starting to get into a situation, okay, now I store that information here, but I also store it here, and when I change it here, I need to manually also update it there, and if I update it there, I need to manually update it there, and then if you add even more places where the data might be stored, you're just starting to write a whole bunch of code just to keep that all synchronized, and if you make a mistake, then suddenly you have not just redundant data, but also redundant data that isn't in sync anymore, and at that point you basically just set yourself up for a lot of fun debugging. What we did basically was just because logics, or rather dynamic fields and dynamic variables just have that syncing built in, we just utilize that, so we don't have to worry about any redundant data. We just have one data structure where we store everything, and whenever we want to change it, we just link a UI element to that and then let you change it through that UI element, and Neos automatically ensures that it's all going to stay in sync.
Awesome.
Yeah, so I just created a small graph, so free-flowing camera would be good here. Basically, mostly people are interested like in the actual values of things, but they are actually stored in something called fields. Like when you open the inspector panel, so when you open the inspector panel and go to an object, you have like those names with a value, name a value. So each of those things is actually a field. They are like the basics of Neos as far as I understand. They're like always synchronized. Exceptions apply, of course, but they are like synchronized through the network. You can read and write from them. You can drive them, and they are the basic building blocks. And there's a component called dynamic field. So compared to a normal dynamic variable component, like the regular dynamic variable component that you find more down here, that stores actual values. So it has its own field. The dynamic field variable that actually stores a field as a reference. So basically, when you have the active state here, we can basically drop that in, and now the variable here is okay. I will not continue this further. This will be too detailed.
Yeah.
But basically, that's the variable now. So basically, we have the field that stores the value, and now that dynamic field uses that field to be its value, like the variable value.
So Autopilot? Yeah. I'm not sure, but I can't see anything. I'm not sure if anybody else is having that same problem. I'm just seeing the graph thing. Yeah, maybe it's a desync issue. Everybody else is fine?
I can't see it.
I don't see it either.
Interesting.
Okay.
I'm not sure why.
Okay.
But it's probably fine. So I hope you still manage to follow the explanation regardless, although okay, this might be just our code being too modular and applying like viewing restrictions to things that weren't supposed to be restricted.
Yeah, we didn't really
It's also
plan.
invisible on the stream, so just so you're aware. I didn't want to.
Okay.
I was like, I'm not really seeing anything. I'm wondering if everybody else is having that problem.
Yeah, we're gonna figure out what happened there after the talk.
Actually, let me see. I will become a regular spectator now. Why?
Okay, more questions? Otherwise, Autopilot is gonna start taking the stage apart already.
Do we have any more questions in the audience? We're pretty clear on our Twitch stream. So is everybody, anything else? All set? Oh, another one. Zizzle, go ahead.
Catch the ball.
Thank you. I'm allowed to speak now. I really like the kind of layered presentation system you guys have put together. And of course, you know, knowing Neos allows you to create your own tools. And then there's another huge step between that and making the tools available for people who don't know how Neos works very well, and making them easy to use. Can you foresee a project in the future where you guys might try to generalize the system you've made and make it a little bit more idiot-proof, as it were?
We have. Okay, so feature creep again.
Of course, yeah.
But we have already a lot of ideas of how we can make the system a whole easier to use and a lot better. So. Yeah. Everyone can basically set it up without any programming knowledge. We have more or less already kind of promised Jason that once the talk is over, we will just meet up and then we will discuss how we can take this thing and turn it into an actual product that we can just permanently install in this world, so other speakers in the future can basically use the same tools to prepare their interactive things.
That sounds perfect.
Maybe speakers that are a bit better at acting.
Well, Jason's a bulldog, so I'm sure he's going to make sure it happens.
Awesome. Any other questions? All right, I think that we're going to start to wrap up. I'd like to thank our speakers from the calendar team, Jack and Autopilot. I'd also like to give a shout out to our camera crew who have been invisible this whole time. The camera crew is led by Carlos Austin, and that brought the multi-camera Twitch stream to you today. So also, thank you to everyone in the auditorium and on Twitch for attending, and thank you for your great questions. This was some great discussion, and it was fantastic that you all came and interacted, and there were balls flying everywhere. This is going to go into a party, isn't it? All right, everyone. Goodbye. Thank you so much.